Okay, so I'm going to do a few of this assignment and then I'll grade the other ones. So I want to go ahead and look at number 3. And where is it? Okay, so we have this image. And again, I told you I didn't want you necessarily to count per se. All right. So, but what I'm going to do here, this is number 3. You can do A for me to grade. I'm going to look at B. But if you look at B, it kind of, you kind of have these long little, I don't know, sets of dots. And they have the same number in all of them. So you don't really, I know there's the same. So I could count to what I said in the directions. I think you could count to 7. So there's 7 in each of these. So I don't want you to take 7 times 5 and say, well, it's an odd number. All right. I don't want you to do math. I want you to look and say, well, if these 2 wings have the same amount, then these would all pair up, because even if there's an odd or an even amount, if I have 2 sets, I can match these all the way up. And actually the same thing with these, 1, 2, 3, 4, 5, 6, 7. Those 7 would pair up with each other and make sets of 2. Because remember, even means they have sets of 2 and sets of 2. So really, these guys don't matter. These guys don't matter. All I have to do is count the number that are in one wing. And if there's 7 in this wing, I know the whole answer's odd. Because, 2 of them will pair up, 2 will pair up, 2 will pair up. But there's going to be 1 dot that's the odd man out. So these guys will pair up as like wings, pair up as wings. Here I have 7, so pair up, pair up, pair up. There's 1 odd dot, so the whole thing is odd. So I don't want you to say an odd times an odd is an odd, or 35 is an odd number. I don't want you to do that. I want you to look at the structure to figure out if it's even or odd. All right, the other one on this page is 7. So let's look at number 7 on this page. So number 7 says if you multiply an even by 3, so we're going to take some even number times 3, and then you add 1. Okay, so what kind of number are we going to get? So we're going to take some even number times 3 and then add 1. Okay, so if I have 3 groups of even numbers, right, that's going to end up being even, right? Because if I have, say, even means they all pair up, right? So like, I don't care how many I have, dot, 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 these would all pair up. And again, same number here, these. And again, I don't really know how many I have, but I know that I have 3 sets or 3 groups of even things. So within each group, they're all going to pair up, okay? Because 3 groups of even things, these would pair up, pair up, pair up. So everything's pairing up here. So then I have 1 more object. And so if these all pair up and I have 1 more object, I know that my answer is going to be odd. All right, and again, you can test it with numbers, like 3 times 2 is even, plus 1 more is going to push it into the odd. 3 times, I don't know, an odd number, 15. Oh, no, we're times even. Sorry, we have to choose an even. 3 sets of an even number. So 18 plus 1 is odd. 3 times 10 plus 1 is an odd. But again, the reason is these are all going to pair up. And then you're going to have that, kind of that 1 extra guy that's not in the pair up group. Okay, so that's how that's going to work. Let's see. Let's look. I'm going to pause for a second and let's flip to the next page here, or the next section. Okay, I'm going to grade 4, but just a hint to our number 4 is that is one really, really long number, and she could add those all up, right? She could add 9 plus 9 plus 9 plus 8 plus 8 plus 8 plus 7 plus 7 plus 7, and then keep going all the way to 1 plus 1 plus 1, and add and divide by 3, but that's not what she does. So, and she doesn't divide by 3 either. So think about how she knows without adding all that big giant every single digit. How can she know it's divisible by 3? She does know the rule, but she's kind of doing a twist on the rule. So see if you can figure out number 4. All right, I want to look at number 14. All right, so let's look at number 14. And it says, okay, so if a whole number is divisible by both 6 and 2, is it necessarily divisible by 12? All right, so if you know that, because again, with 6, remember the rule is like for 12, if 2 works and 3 works, right, then I know that 6 is going to work for the divisibility rule, right? Like it's even, it adds up to 3. I know 6 is going to work as well. All right, so what about, does that always work? Okay, so let's think. If I have a number like, say, 18, right? Let's look at 18. It has 1 and 18, 2 and 9, 3 and 6. And again, check through the square root, which square root of 16 is 4. I'm going to try to get out the sun a little bit there. All right, let me tilt my camera a little better. All right. So the square root of 16 is 4. Whoa, there we go. And so 4 doesn't work. But notice that 2 works and 3 work and 6 works. So that's great. All right. So, but then is it necessarily 6 and 2 both work? Does it necessarily divisible by 12? Well, 12 does not go into 18. So like here's an example where 6 and 2 both work and it does divide into 12. It gives you 1. But 18, 6 and 2 both go into this. And again, if I get a remainder, right? I get leftovers. So 18 is not divisible by 12. And there's other examples. 18 is just one of them, okay? All right, B, if a whole number is divisible by 3 and 4, is it definitely divisible by 12? All right, so let's look, obviously, up here, 3 and 4 go in here. And again, we've already proved that, 12 goes in there. Let's think of other examples. Let's see that 3 and 4 goes into it. Let's look at 24. 3 and 4 both go into 24. Let's see, 12 seems to work. 3 and 4, let's see, 48. 3 and 4 both go into there. It seems for part B. So A is no, right? And example, I came up with 18. There's other ones. B seems to work. I mean, it does with what I've tried so far. So it seems to work. Okay, C, based on your example, so I think the first one's a no, and I think the second one probably does work, so I think that's yes. Okay, based on your answer to C, determine whether, all right, so we have 3, 3, and again, this is one really long number. Okay, so we need to determine if, let's see, based on, do we think it's divisible by 12? Okay. So it looks like having 6 and 2 works not good enough. It has to be 3 and 4. So the rule for 3 is add up the digits. Remember, 3 and 9 are the only ones where you add up the digits. And so it looks like this one's 3, this one's 6, 9, 10, 11. Oh, what is it? Is that 18? So 16, 17, 18. Yeah, this one's 6. And this one's what? 7, that's 15. And then this is what, 12. Now, I'm not going to add these up because you guys get 3 is divisible by 3, 6 is divisible by 3, 18 is divisible by 3, 6 is divisible by 3, 15 is divisible by 3, and so is 12. So I know if each part is divisible by 3, when I add them up, I know that the sum is for sure going to be divisible by 3. So I'm not going to waste my time adding those up. So 3 works. Okay, what is the rule for 4? Okay, now remember, for 2, 4, and 8, you look at digits. For 2, you look at the last digit, right, to see if it's even or ends in a 0, 2, 4, 6, or 8. For 4, you look at the last 2 digits, and for, let's see, 8, you look at the last 3 digits. So you look at 1 digit, the last 2 digits, and then the last 3. So those are all interrelated, looking at 2, 4, and 8. You do not add up the digits. That only works for 3s. All right, so let's look at the last 2 digits for 4. Does 4 go into 16? Yes. So it works for 3, it works for 4. So I would say yes, it's divisible by 12. All right, now, why does 6 and 2 not work? Okay, let's look at the prime factorization of 18. I'm going to do 2 and 9 and 3 and 3. The problem is that when you're looking at, say, this and 12, so here's 2, 2, and what, 3? The 2 and 3 they have in common is the 6. Do you see how there's not an extra 2 that they have in common? So that's why 12 doesn't go in this one. Okay, 12, I would need another 2. I need an extra 2. So the problem is when you look at 6 and 2, and then you're like, well, there's 6 and 2 here. This 2 is part of that 6. Do you see that? Because if you use 3, you're using the 2 and the 3 from over here to get this 6. And so you can't double count. So that's why the rule, if you have 2 and 6, 12 does not always work as far as divisibility goes, because the 2 that goes in here and this 2, the 6 is these together goes in there. And so you don't have an extra 2 to make a 12. So you're kind of double using that 2 because 6 has a 2 in it as well. And so you don't have an extra 2 to make the 12. Okay? But then why does 3 and 4 work? All right, well, if you look at 3 and 4, they have nothing in common. So if I had 24, my prime factorization is 2, 2, 2, and 3. All right, so instead of looking at that, I'm looking at 3. Well, there's a factor of 3. And then does 4 work? Yeah, there's a factor of 4. Do you see how there's no overlap between these? 4 has no factors in common with 3 and vice versa. So then I know together that I can make a 12 because there's no overlap between these guys. So that's why if you want to know 12, you have to look at 3 and 4 and not 6 and 2. The problem is 6 and 2 have a 2 in common, and that causes a lot of problems. All right, hope this went well. Finish the others and I will grade those. Good luck.